Hello everyone, I'm Mohnish and today I've come up with another new project which is plotting the heat maps according uh, to the percentage of the blood in heart and the percentage of blood leaving the heart at each contraction of a smoking and non-smoking and person who died with cardiovascular disease. So let's not get too much worried and let's get overview of today's video. So we are going to come up with a new library which is cborn as sns. We are using this to plot heat maps. So in this video we are going to learn what are heat maps in python, and we are going to learn how to make our own heat maps using the cborn library in python. So let's run our jupyter notebook. Okay, it's already running. Yes. So let's get started. Uh, okay, so let's get to the tasks and are plotting a heat map which helps you to visualize percentage of blood leaving the heart at each contraction of a smoking and non-smoking person heart. And let's start with one. Plot the heat map to visualize percentage of blood leaving the heart at each contraction of a smoking and non-smoking person. So we have to compare the smoking and non-smoking person's heart rate here, heart and like blood flow leaving at each contraction of the heart, and we have to plot a heat map. So what is a heat map? So I just want to show you some examples here from the internet. You see, heat maps are something like this. Like you see, like there are some color code decided, and there are shades of colors, and the shades of colors represent the intensity, like the quantity over there. So here green represents 1, red represents 25, and the changing shades, like the transition of the shades, represents the numbers between them. So that's how the heat maps look like. But in this we are not going to have squared heat maps because we are not having equal number of rows and columns, but we are only having like some 1 million rows and only like 1 million columns and only 2 rows. So we are going to get some rectangular things instead of the squares you are seeing here. So our heat map is going to be different. So you see the heat maps, you see like this for temperatures and all that. Red represents hot climate, and why blue is for frigid and cold, and green is for okay and all that. So you have came across heat maps in your daily lives also. So that's not a new thing, but you must have not known the name. Like many of my friends did not know, so I thought to say that before the video starts. And let's start the process. A normal healthy heart will never completely empty, but it will pump 55 to 70% of blood that's inside it. An injection fraction of 55 to 70% is normal. 40 to 55% is below normal. Anything less than 40% may indicate heart failure, and below 35% there is a risk of life threatening arrhythmias. So that's the we are segregating healthy and normal and all that, which we do in our each video. So let's get to our task. This is the image of the heart which I've got from internet, of course. And this is also a new library. This is ipython or display image. So ipython is library. From that we are including display, and like from that display thing we are importing the image function, and using the image function we have a file saved as heart.png. We are trying to display that, which is not getting displayed now also due to some lag here. So let's wait for the lag to get solved. Meanwhile, we'll just see rest of the code here. The right side of the heart receives oxygen, poor blood in the veins, and pumps it to the lungs, where it picks up oxygen and gets rid of carbon dioxide. The left side of the heart receives the oxygen rich blood from your lungs and pumps through the arteries and rest of your body. So let's check if the image is there. So you see heart.png. uh, I don't know why it's taking time to load, so I'll just explain it meanwhile from this. So even this is taking sort of time, so I think we'll just rerun our notebook once. let's control C, and it's shutting down 3 kernels, so it is running here. And it's okay, so let's get started. Jupyter notebook, yes. So it might be wasting little time, but the notebook is not working, so we need to restart it. So that's not a problem. So as we are restarting it, it may take time to load the libraries again. So the libraries were preloaded for me, like I was working on them, I checked them, then I was making the video, so they were preloaded, so it was kind of faster. But this may take some time again. So let's go to our file here, and before that, uh, the heat maps concept is done, and the heat maps are a very good way to represent data because it's convenient for people to understand sometimes. And sometimes the data which is irregular, like you have to plot a data on an irregular piece of paper, like a map, to say, or a area which has more bacteria in it. So heat maps rule that area, like that sector here. So okay, so we are having a few checkpoints, so we'll just restart our kernel, and we are going to clear all the output here. So you see this output is there, so it means some preloaded thing is already there cluttered here, so we don't want that here. And let's normally look at the heart.png from the desktops 197, and something we'll open with paint to save resources. So you see, from here the blood goes in, and then the blood gets like processed, and it goes out, and we are able to like transport blood in from a contraction. So the contractions here give us the blood here, and these contraction matter a lot. These influence the pulse rate of a person, and when it drops to 40, it's dangerous for the person. So we are just going to check the risk. We can't stop this because we are not doctors, but we can see the risk of people who can have it. So it might help the doctors. This data might help the doctors. So the data, let's have a look at the data set too. Heart failure clinical records data set, which is from Kaggle, I think. So this is the age, it has anemia or not, I don't know what is this really. And diabetes, ejection flow rate, fraction, like how much blood is ejected and all that, platelets and death event and all that, smoking and all. So that's what we need, and not much from it. We don't see anything. And now let's get started. We are going to import the libraries, and we are going to group the data frame here by age and smoking. Here we are grouping it by two things, age and smoking, and by ejection fraction, and we are getting the mean, and we are resetting the index. So if you think I'm going fast, I'll just say here, okay, wait, warning, numpy version directed 1.23.2. Okay, so there is a problem with the numpy version, but will just ignore this warning for now, because Cborn SNS will work well without numpy here. And now we are grouping it, and you see we got grouped it by age and smoking, and by the ejection fraction. By age 40, 1, 40, 0. And if it's 0, then what's the ejection fraction? If it's smoking, then what's the ejection fraction? You see, ejection fraction for smoking pill is less here in each case. Yeah, it's less. So I think this is not the erroneous data. Like a few videos ago, like 1 or 2 videos ago, we got few erroneous data, like smoking people were more healthier, like they had better heartbeats. But I think that was some we got some erroneous data, like that there's an error in the data set. So we have got rid of the data, and now let's plot a heat map. Just plot a heat map and see what's happening. So you see, I already told you are going to get rectangles because we have infinite number of columns but only 2 rows. So here 1 represents smoking and 0 is non-smoking, and these are the age groups 40, 41, all that. and the color here is the intensity of the ejection fraction through the blood from the arteries and veins. So here a lighter shade or yellowish shade, orange yellowish shade, represents a good number which is above 50, but blue and purple shade is below 20 or 30, and that's dangerous. Of course, everything is dangerous in life here. We have got it, and you see there are some white spaces. So white spaces are for those things where we do not have the data only. So we are not having the data for all age groups, but according to the data set, we have kind of some 299, around 300 people's data. So around in 300 people we could not cover all the age groups, but that's okay. So the white spaces are for the age groups which are not there. So according to this data set, there are less smokers in this clinic. So you see here, that's the data. So ejection flow rate can be identified as, so if you study this and you can make your studies in this data, and you can get few conclusions. So like you see the smokers have a blue color, like bluish shade one, like bluish shade bars here, heat maps or the boxes. So it means they have less heart rate. And you see if you go to non-smoking one, they have a yellowish and kind of you be like fully yellow. And you see we have like some 4 to 5 like boxes which are bluish shades. So they have a high risk of some diseases with heart, smoking and all that, because they might get, you saw the 10 years coronary heart disease thing. If you have seen earlier videos, then you might understand here. So zero smokers, one conclusion: heart of people who smoke releases less percentage of blood in each contraction, and what we discuss now. And plot a heat map to visualize percentage of blood leaving the heart at each contraction for people who died, not for the people who are like not for smokers here. So just we are changing the parameter from here to that smoking thing here. What was that thing? Smoking. So I'm that smoking and just changing the parameter to this, and everything is same here. Like not even a single piece of code is going to change here. That's it. And now we can see the heart of the people who died due to cardiovascular disease releases less percentage of blood at each contraction. So this is death event. 1 is dead and 0 is alive. So that's simple here. And you see blue color for dead people, and blue color represents here, it represents the less heartbeat and ejection flow rate. And here also we have some slightish bluish like blue yellow thing, but partly these are like shifting towards yellow. So these have less, like more like ejection flow rate. And what I want to now, we are going to discuss this piece of code, like this 4 lines, in a detailed manner. So PLD dot figure size and all that, so that's old one, so we don't need that. So our new concept is cbond dot sns here. So you see even I imported that here, and its requirement was numpy version 1.1 to 1.6.5, but I have 1.23.2, so it just gave me a warning, but we don't care about that. Okay, so cbond.sns, so it's used for plotting heat maps. So we imported it as sns because that's how people import it, like most of the people. It's convenient. And of course, let's go to the heat map df. So what is PD is pandas here. PD, we are giving an alias name to pandas as PD here, and matplotlib .pyplot as PLD. Then what does pivot table do? So I got image from the internet for explaining this. So you see this is a data set here. It has John, Sammy and all that. Its gender is this and age is this. What does the pivot table do? It will transform this data from male to female. Like you see John, Sammy and all that are unique values. Like they are the primary keys. You in SQL you call these as primary keys. So according to that, these primary keys are unique. So this unique, we don't need unique data in the heat maps. We need a group, like we are going to cluster the data, or we are going to classify the data into two types. So in heat maps we are going to classify it. So pivot table does it for us. Like you see male and female are a broad classification here. So you see 50 people percent are male, it gives the percentage of gender, and age group less than 18, greater than 18, less than 18, greater than, like it doesn't do by 18, like it doesn't does by 18. But here we have like if we give some parameters, then it can do by 18, and it gives a count here. Like this is how it transforms the data set in pivot table. So what we need clusters and collections of data for heat maps, and not individual primary or unique data sets. We need like clusters and collections, and you understand, the data needs to be group and not just unique or one value. So we are using pivot table, and values is ejection fraction and death event. So values is ejection fraction, so it will take the values from ejection fraction. So these values are shown for the ejection fraction. You understand, like 40 age group who are alive are showing some 30 according to this color, 30 to 40 here. So 40 is the ejection flow rate of their heart, you understand, and the index here, that event is index. So 1 and 0 are the indexes here. You should understand, my index are the events here, like by what, like you can see that it's the y-axis here, and columns, you understand, columns is the age. You see that I'm repeating it, like columns, and data is death dot data frame, which is this one. I did not go through this code because we are using it quite many times in our videos. So if you are not understanding, you can watch the earlier videos. And we are SNS, so we are using SNS here. Dot heat map. So this is creating a data frame here. So this is not a heat map. This is creating a data frame. It's converting this data set into this pivot table, like in this format. Not exactly this, but in this format. And it's like heat map is a function, and we are sending the heat map parameter, and CMap as plasma. So what is a CMap here? CMap is a color map. So we have different types of color maps in Python. So I'll just go through some CMaps in colors in Cborn SNS, and let's go to Geeks for Geek, and we'll just go through some CMaps. Current it. Okay, I'll just go for this gray, and let's see what happens. So now as we do this, you see there's a change in this. It becomes black and white. Like black color represents more heart rate, and this color represents less heart rate. So and let's okay, so it's I'll ask for sign in, and I will never sign in here. And we are going to get terrain R here. So we'll just try this, and you see you get this. But you know what I found most relevant for explaining to you people, of course, is this one. Like it's kind of good one, like it will help us instead of us, and it's a list of all the possible palettes here. So I'll just try some random one here, and let's check what happens, and let's enter. You see it becomes like this. But of course the one which we are using, the purple to yellow transition one, is the plasma transition or plasma palette. And that's it for the video, friends. Thank you for watching this video. If you are liking this video, subscribe to the channel and smash the like button, and stay tuned. We'll be getting to more informative videos, and bye bye.